science enthusiasts. Welcome to SciChat. Every week we bring amazing experts to you to enthrall you with their area of knowledge. My name is Jason Zakowski, aka Dad Guy, and my co-hostess with the mostest is
Chris Zakowski, aka Mommy Fave.
Today we are broadcasting to Twitter Spaces, to Clubhouse, to Facebook Live, to Wisdom, and as well recording. So if you miss it, you can catch us on the RSS feed or this chat again on Twitter. Without further ado, welcome Dr. Yane Valdez. How are you doing tonight?
Very good, thank you. Very good. Yeah.
For people that don't know, the doctor was our guest on the first episode of season 4. So it was such a good conversation. I was like, oh man, this has to be episode 1. So thank you for being back a second time to talk to us.
Oh, thank you very much for inviting me. I had so much fun too.
And you're an immunologist. So what's you have a doctorate and you're an immunologist. What's your training in science? What does it take to be an immunologist?
Well, my experience is a little bit different than other experiences. I am first. I wanna let you know all that I'm joining from the traditional, ancestral, and ancient territory of the Musqueam, Tsleil-Waututh, and Salish peoples. So I am here in Vancouver, and however, I came to Vancouver almost 25 years ago, or a little bit more than that. So I'm originally from Peru. And so my journey starts with me being a curious person, and I always wanted to be a paleontologist.
You wanted to study dinosaurs?
I love the idea of evolution, paleontology. Yeah, that when I was a kid, I really wanted to do that. So I joined science because it was natural for me to be always like curious, investigating. I was so fascinated by plants, animals, like frogs for a particular reason. I had such an admiration for frogs. And in high school, for me, the idea of how a tadpole turns into a frog, it was just like, what is this?
Magical.
So it was just against, exactly. So that's what from like to go into science. So when I was in school, I went to, in Peru, we have an undergraduate that takes around 5 years. And in biology, so we take every single biology, which means single thing that is living, and the composition of, like we say, all the chemistries, all the botany, zoologies, everything. And then we have 1 year that we call to licentiate. So then we have to kind of decide what area we want to be in. So at that point, because my faculty had only 5 options, I decided to go into microbiology, which was also, I mean, science is just, whoever doesn't like science, I don't know, you're missing out. I mean, I was just thinking in bacteria and like even to make beer, to make breads. And I was like, oh, this is fascinating. This is good. So I took microbiology and I had my degree in microbiology. So over there, it's important because then you are in a college, in a place that you are like a biologist. Now you can teach or you can actually work. And then I just happened to know a professor from Hopkins. And he was in Peru, and he used to work back and forth from Hopkins to Peru, and he was studying epidemiology of many infectious diseases. And he invited me to join his lab. So I traveled to Lima and I studied a disease called cysticercosis, which is a disease that is affected by the larva stage of a parasite called Taenia solium. And so while I was studying there, which again is fascinating, studying parasites.
Oh, parasites are so weird. They're so creepy.
They're so creepy. That one was.
They're creepy weird.
It was like it was horrible. It has a small, tiny head, like a like a needle, teeny tiny, but has a long flat body.
Ugh.
That's what it's called Taenia solium, and it could live for decades in the intestines of people. So, and these are the flatworms.
Oh.
But the eggs of that parasite that we can't see it. They are microscopic. They can go and infect, we say, pigs, which are the intermediate stage. But sometimes they go into human. So if you eat food that is contaminated with, we'll say, this egg, you ended up getting this larva that grows usually in the brain.
Oh, no. So it's not good. This is bad news.
This is bad news.
Okay.
So, yeah, and people ended up with epilepsies, headaches,
Oof.
who knows, many things. So I work in that area. But at that point, there was an epidemic of cholera in Peru. And I seen how devastating it was. It was like, especially young kids. And for me, it was a shock because I grew up in the Andes in Cusco, which is in the mountains, and is the capital of the Inca Empire. So it was just different. So going to a big city like Lima with millions of people and seeing people, young kids dying, so changed me as a person. And that's when I study molecular biology and microbiology. And and then I love evolution. I still looked at it, but then I started working more into the idea of saving lives.
Oh.
So when I came to Vancouver, I actually joined the Biomedical Research Center to study immunology.
Mm-hmm.
But I didn't have a doctorate degree. I had a master's degree in molecular biology. So then after a few years of working, 5 years of working, and now as a mother already, I thought that it would be really good for me to actually teach my daughter at that point to continue what your dreams are. So my dream was to be a doctor and then to be an immunologist. So then I applied to study. I went back to school and studied microbiology and immunology. And so I work in the gut again, back to the gut. And
Was that when you were studying like Salmonella and Helicobacter pylori?
That's exactly right.
Yeah.
So I study Salmonella and what makes the difference between salmonellosis or enterocolitis or diarrhea and other diseases like typhoid fever, which are more systemic diseases. And that's when I was telling you how my job was to actually understand how Salmonella enters the gut, because the gut is protected, with mucus, with cells, microbiota, and other things. But what makes Salmonella so tricky, like smart pathogen to enter, and how the immune system also evolves to fight pathogens like Salmonella. Yeah. So my whole thesis was understanding those interactions.
Salmonella. Doc, have you ever been infected with Salmonella? Did you ever get Salmonella poisoning?
Actually, as far as I remember, no.
Okay.
The other day, my friend of grad school came to visit, and we're washing our hands on every time, and we were realizing, why do we have this habit? We wash our hands constantly, and we thought that's why we never got contaminated in the lab,
right? Because
you're washing your hands constantly, and there's a style of washing hands as well,
Mm-hmm. Yeah.
Yeah. No, that I know, but who knows? And maybe traveling. When you're traveling, you could have traveling diarrhea that we call.
Yeah.
It could be caused by many enteric pathogens like E. coli. It could be also Salmonella. So, but because those salmonellosis as enterocolitis just lasts 2 or 3 days, and it's it produces paying and vomiting and all this stuff. So, but it's self-limiting, it's your body that is pretty much defending you and not allowing the bacteria to go in. So probably I had some kind of food poisoning, but I can't confirm it was salmonella or not.
Right, yeah.
But during my lab studies or whatever, not, I didn't.
Okay.
Yeah.
If you're just joining us for SciChat, we have an amazing expert, Dr. Yane Valdez, with us tonight. It's going to be a shorter SciChat because our guests can only stay with us till the quarter to the top of the hour, quarter two, something. So we'll open up the floor to questions near the end. Doc, I was wondering, I was re-listening to our chat and you talked about dendritic cells, and I remember I went down the biggest rabbit hole of dendritic cells after we chatted. Could you tell everybody what they are in the immune system? Because they are so weird that these are inside us.
They're fascinating cells. I tell you, I got in love with these cells. And they are like, so in immunology, imagine it's like your body has different layers of protection. Mm-hmm. And so we classify that way because it's easy to understand. You have the barriers, which are the physical barriers, like we'll say the mucus, the skin, the tears. Those are the physical barriers. Once you pass that, you have other cells that are really at the interface. And we call it cells of the innate immune system. And why are there? Because they want to respond really, really fast. So if a pathogen, for instance, passes the mucosa, the tears, or these physical barriers like the skin, mm-hmm. then there are a group of cells that are sentinel cells. They are always taking care. They're always looking at are they dangerous or not? And they know this. They learn through our lives.
So they're always on watch. They're just always looking. They never, ever stop.
Absolutely. And they're called sentinel cells. Then those cells are important because they alert what we call the adaptive immune system. The mm-hmm. adaptive immune system are all the other cells that we know normally, like B cells that produce antibody or T cells that kill the pathogen. So what a dendritic cell does, the job is fascinating. So it senses. It has a lot of arms. Imagine an octopus like.
Like an octopus cell, right?
Yes.
Okay.
So it has sensors in all the hands, and it's able to recognize, is this dangerous or not? And then once it recognizes that it's dangerous, it's that pathogen, we'll say, and migrates, runs to a special place called lymph nodes, and they're like a site of conversation, a communication. Mm-hmm. But in the way of eating, in the way of migrating, it eats that pathogen, and when it arrives to the place of conversation, the lymph nodes, it presents. It shows to the B cells and the T cells and shows them. And this is the pathogen, I'm bringing it. And so then the B cells and T cells recognize it, and they start working towards producing antibodies or producing more, like we say, what we call cytokines, which are molecules that will kill this pathogen. Huh. So that's what is called dendritic cells and antigen. Antigen is the molecules in the pathogen. Antigen presenting cell. So it's we say it's a link between the innate and the adaptive immunity. It's a professional antigen presenting cell. That's what it called.
I just love that, like, its job is to like eat the thing, and it goes to our lymph nodes, and it's a tattletale. It's like,
it is, yeah.
It's
yeah.
It's like,
and
hey,
it's what's up. I'm looking at now there are images like you could see in microscopes, and you can see how they migrate. By the time that when I also change shape a little bit. By the time when it's a sentinel, just underneath the epithelium, for instance, it has this like huge dendrites. This again, imagine the octopus.
Yeah, the octopus.
But, once it eats the antigen, it turns a little bit more roundish.
Oh.
Because as a like octopus, it will be like a little bit hard to migrate. So then it's taking in the lymphatic system quickly to the lymph nodes.
Oh my goodness, it becomes aerodynamic.
Yes. Oh no, changes the shapes immediately. Yeah, absolutely.
What?
It is incredible. I like watching those.
And okay, they got little, like their octopus arms are grabby, right? Like they are
grabby. They're grabby. I told you, remember that they're able to take the arms between the two cells and grab bacteria inside and sample them, eat them.
That's terrifying. It is terrifying.
But it's actually good.
I know, it's so good for us. It's so good.
Yeah. So that's what the immune system is doing. Every day that you pay attention to your immune system, the cells are working day and night.
How? Yeah. Like when you were becoming an immunologist, like, was this just like a whole, I didn't know this before we talked. And it's like, every time I talk to you, I'm just filled with wonder that these creatures, these little cells are inside our bodies. Like, it's bananas, Doc.
It is. Those dendritic cells, definitely, they were discovered, like we'll say 45 years ago, more or less. And the person that discovered the cells, his name is Ralph Steinman, and he was a professor. Actually, he was Canadian, but he went to Rockefeller and he discovered the cells in the spleen. But he discovered the cell and how it behaved and how to start growing it in vitro. And then we learned so much in those 40 years about the cells. Now we know that there are huge classification of the cells, and they actually divide the jobs. Some of them, as I said, present the foreign, we'll say the dangerous signal. Other ones are telling the T cells, oh, don't worry, I sampled this in the gut and those are good bacteria. Don't worry about it. So they
ate it and it's like, it's a good guy, don't worry.
Exactly, don't worry.
What?
So these are the tolerogenic cells. They're being used for therapy. So Ralph Steadman, unfortunately, he got the Nobel Prize, and just before he got the Nobel Prize, he passed away from pancreatic cancer. But he was working towards using the cells and for a kind of therapy. So what they did is you can get your own cells growing in a petri dish, and then feed the cells, those dendritic cells that I tell you, and 2 more antigens, and put it back to you, and then the cell will migrate and will teach the body that those tumors are bad. So that he was working towards that. Yeah. Wow. So unfortunately, he passed away. From basic science, from understanding what the cells do, we can actually now use those cells to help us out. That's called immunotherapy. Now, a lot of this using this basic knowledge that we acquire over years to actually make it work for yourself. It's like the vaccines that we have now. Mm-hmm. So your cells make the RNA and then present it again. The dendritic cells will have to go and present the antigen, and the other cells will create the antibody. So pretty much your body is doing everything, because our body was developed to fight against those pathogens. But it's a tug of war. Sometimes the pathogens overcome, the resistance of the immune system and the defenses, and that's when people die. So yeah.
I have a question that has been stirring in my brain since we talked on the Science Podcast. And like, the dendritic cells are a cell. Are there pathogens that infect dendritic cells? Like, are they susceptible to infection by virus?
Yes, that's a good question. Yes.
Okay.
Yes, there are pathogens that could infect dendritic cells or other cells like macrophages.
Like macrophage.
For instance, Salmonella is able to survive and live inside macrophages.
What? Like the white blood cells that eat stuff, the Pac-Man ones?
Yes, that's correct. So, but Salmonella uses kind of as molecules. It has kind of a needle-like structure that we call type 3 secretion systems, and shoots proteins to the macrophages and takes it as hijacks the cell. Hijacks the cell. So the cell that should be eating it now is a home for the Salmonella.
Oh my goodness.
And so the immune system doesn't see it because it's inside
the macrophage.
Yeah. So this could happen. And in my experiments, yes, Salmonella is able to survive inside dendritic cells, unfortunately.
Huh.
Yes. But there are other cells. That's why we have layers and layers and layers.
Right.
So there are other dendritic cells that are able to see and recognize which cells are not well.
Like an infected macrophage.
Infected macrophage or infected dendritic cells.
Right, okay.
The NK cells, that's their job. NK cells are the ones that looked at the cells. Are you okay or not? Are you okay or not? Are you infected or not? Oh, you look that you're infected. And then looks surveys the surface of the cell, and when it finds out that the cell is infected, just kills it.
They just kill it.
Without mercy.
Oh my goodness, that the immune system has no chill. Can you imagine with people are you sick? I don't feel well. Well, done. I'm the immune system. That's it. No more you.
Have you ever seen a cartoon of a natural killer cell or NK cell?
No.
Oh, you should. Everybody depicts.
I would lie. If an NK cell came up to me and it's like, how do you feel? And I was sick, I'd be like, it's all good. I'm fine, because I know it's going to murder me.
NK cells are running around checking every day if you're producing a tumor. Oh, they are killing all these tumor-producing cells. Oh, they are killing all the cells that get infected.
The immune system is just bizarre. It's so bananas. I
Yeah.
Wow.
It's fascinating. So if your cells in dendritic cell or macrophage or a B cells or a T cell, yes, it's susceptible to be infected by or bacteria or a virus. So there are other cells that could could get rid of them. Yeah.
What? Wow. Okay.
And the whole reaction that we call the whole reaction is the inflammation. That's why you feel sick, because everything is happening at the same time.
Oh my! It's just, I don't know. It's fascinating. Like I get so interested in it because it feels like when I was young, I loved reading about battle tactics, like in World War II, like battle. And this seems like it's just it's like the armies going against armies and like layers upon layers of strategy,
Yes. It's, I think we accumulated all this through evolution, Even, even bacteria has defense mechanism against viruses because bacteria gets infected with viruses. So then bacteria had to evolve and defend themselves from these viruses. And we as a species, as a human, we accumulate all this through evolution.
It's so fascinating. Well, before I derail us anymore with me asking you question after question about the parts of the immune system, scoping things out bigger, you are part of this organization called Science Up First, and which is a science communication directive with vaccines. I was wondering if you could just talk a little bit about that.
Yeah, so actually I was part of the COVID-19 Resources Canada, which is a a grassroots initiative created during the pandemic in order to give the resources to Canadians to act properly. And at the same time, there was another group called Science Up First.
Okay.
And that was created to inform, to have proper information and try to fight a little bit disinformation or misinformation. So I am kind of a part of the Science Up First, but not directly. But
Right,
I
okay.
do advise, and I did a few things with them, with my friends, with Krishana, with Tim Caulfield.
Oh, I love
and
those
with
guys.
Those guys are
Krishana
they're
and Tim
like
Caulfield's
good friends.
amazing. Yeah.
Tim is, I know him for a long, long time. So, and so that's the idea was to start like giving information to people in a way that they can understand and digest. Again, for instance, if I speak with immunologists, our language is different. Absolutely different, especially immunologists compared to other groups, because everything comes in acronyms and everything comes in molecules and numbers. So they, every time when people ask me, well, how many languages do you speak? I said, I speak Spanish, English, and immunology. So they understand, scientists understand that immunology is a different language. But then the problem for us, for scientists, is that we didn't do a good job trying to communicate all that we are understanding to the public. So that doesn't surprise me now that people don't know, especially in cases of uncertainty like the pandemic. You don't know who you want to believe, because we didn't really in open. We. Like we'll say, scientists usually have this character of introverted and they're in their own space. But I think we need to do a better job to communicate to the people, to be more transparent and teach them how science is. Science is like, it's not rigid, it's moving constantly. And we are humans working on that. So that's what we wanted to do with Science Up First. And with COVID-19 resources, my job was pretty much what I'm doing here. I will open a Zoom meeting, and if there was people that didn't understand about vaccines, what is a vaccine, from what is an antibody, so I will actually start teaching and passing on my knowledge in simple terms. The good thing is that I have kids, so then I have to I will teach my kids and his friends, and then if they understand, so I knew that the public will understand.
They're your guinea pigs.
Yes. So that's what I was doing. I was trying to inform, but also at the same time, I was looking at the data, what is happening, what is going on with with the new waves, which variants are coming, and little by little, I started focusing more in long COVID.
I saw you've been posting about long COVID. Yeah,
exactly. So I think, unfortunately, unlike the US or the UK, we are falling a little bit behind in understanding long COVID and giving the resources for treatment or research. So that's why I'm advocating a lot for that. So that's really,
yeah. That's so important. Like personally, myself, one of my colleagues at our school, he got long COVID, and is still unable to teach. And I taught a girl who had long COVID, and like the symptoms from long COVID are bizarre. Like are you finding that there could be tiredness to heart palpitations to shortness of breath to all of these different things? And this poor girl, her heart would just like randomly race for no reason. And we had to quickly assess if we had to call the hospital, like call for an ambulance. Like, it's just, that is interesting that you're switching to long COVID. We're just starting to realize it's maybe a bigger problem than we thought.
That's correct. Yeah. It's people right now, the studies say that there are over 200 symptoms, and there are families of symptoms, but the most common are, like we'll say, brain fog and fatigue. But because the pathogen, in this case, COVID, could go in any organ, so it's not surprising that we'll say the brain gets affected or the circulatory system or the muscles. And so it's going to be a very, very difficult. We are calling it a pandemic between the pandemic.
Mm-hmm.
And it's going to be very hard, very, very hard.
Well, I'll see. I know you've posted, we will, I'm just trying to think because we don't really have a ton of time left in our chat, but if everybody wants to, if people follow you, they can see some of the awesome things you've been tweeting about, long COVID, for example. And I've been reading them and keeping up, and it's it's good to know, but it's also kind of, it's sad in a way, that people are suffering from this, but information is important.
Correct. Yeah. In reality, we had problems like long COVID long before the pandemic. We had other, we'll say, post infection sequela, in this case, is long COVID, but even people in the past, people with HIV, people with other pathogens, with other viruses, had other problems like, we'll say, chronic fatigue syndrome.
Huh.
We don't know where it comes from, but they are thinking that might be associated to like a sequela from a prior infection with a pathogen.
Oh, like a prior infection is causing... It's a contributing effect. Oh, okay.
Exactly. So, but nobody really give it much importance, unfortunately. Like people with HIV had suffered the same, and people with SARS-CoV-1, the first coronavirus, had those problems. But right now, because millions of people got infected, so now you see the reality.
We're seeing it at scale. Yeah.
So it's unfortunate, but it's a reality that we didn't face it before. So now we just need to address it.
Mm-hmm. And the people with long COVID are debilitated, so they don't have the same advocacy as somebody who's healthy and walking around, right? So
That's
they're
correct.
kind of invisible.
That's correct. And it could be anything, It doesn't mean that, like, for instance, those invisible diseases are the ones that you don't see them, but they are debilitating for people. And so that's, I guess, my advocacy, because right now I see during those Zoom meetings that I described before, I was talking to people and I saw two major things. One is that COVID not only was a physiological problem, but also was an emotional problem. I had people that came and their families were divided. Some people wanted to get the vaccine, the other people didn't. Families, and even close families got broken by COVID. And the second factor was this, which is the chronic fatigue-like syndrome, and that was in term like long COVID. So it was very sad. So I'm just trying to help.
Well, thank you for that. We only do better when we're empathetic, and then we have awesome folks like you helping. So thanks for that, for us from society and in Canada. We appreciate that.
Thank you. I think, everybody could do something. As you said, those are invisible diseases, but just to be empathetic, just to be helpful with somebody, I think it's important. It's the only way we are going to get out of this.
Mm-hmm. Doctor, I know you have to go in about 10 minutes. Normally we leave questions for a little bit later. Are you okay taking a few questions before you go?
Absolutely.
Okay, so because our guest can't stay the whole time, we're going to open up the floor to questions. So I think our questions can stay along the lines of the immune system. We want to give folks in the show tonight to ask questions to our expert. So if you have questions about salmonella, I left a whole bunch of unanswered questions from salmonella. If you have questions about Helicobacter pylori, we didn't even talk about that, or just the immune system, or even vaccines in general, because you are one of the vaccine experts with a couple of organizations. So if you have a question for our guest, you can request to speak, and I will do my best to move you up on whatever platform you're requesting to speak from. Chris, did you have any questions, or are you doing okay?
I'm doing great. Thank you. This is fascinating.
Yeah, I think,
and I really think it's the long COVID is getting the attention it deserves, because I think it was kind of poo-pooed in the beginning, and people had to be really strong advocates for themselves that things weren't quite right.
Yeah. Actually, we are just maybe in a couple of weeks we are going to start bringing a more resources and more information. And so just stay tuned. I can't tell you exactly right now, but yeah, maybe in a couple of weeks we will have more information about long COVID in Canada, because we know a little bit more what's happening in the States or in UK, but not yet in Canada, very little. And I think the stats just came yesterday from Statistics Canada, and they're estimating a few million people with long COVID. So stay tuned for what is coming, and we'll ask you to please maybe retweet, bring more advocacy. Yeah, because I organized a day, a national long COVID awareness day. That was on June 9. And so we brought experts, and we got patients, advocates, from basic scientists to, we say, clinicians and policymakers, because anything has to go back from patients to policy and policy back to patients. So it was amazing. But now we are going to bring more awareness, and we are going to prepare for the next year awareness day as well.
You betcha.
So, yeah.
We will retweet that. You betcha. We do have somebody up here to ask a question. Peaceful Warrior. What's your question for our guest tonight?
Yes. Good evening. I have a question concerning there was a criticism of the way the vaccine for COVID was developed so fast on a fast track. And because of it, some people were of the opinion that because it was rushed, it might be detrimental to people. And in particular, I guess because it was mRNA, I think they call it.
Yeah, actually, it's quite interesting. The person that developed the vaccine, Kathleen Carrico, is coming to Canada, and she will be coming now to UBC this coming Monday. And actually, her work is not that recent. Her work is around 30 to 40 years ago. So the work of the RNA, like vaccines, are actually almost 40 years, and they were done for cancer. And but however, when the pandemic came, it was used the same platform for the virus. So the work first is not that recent, and it was used only recently because we have a recent virus, a new virus. So that's one thing. And the second thing is that there was none of the safety steps were actually rushed. They were done. And because we had a crisis, so we had to have a lot of resources for that, including money, including all the facilities, and everybody had to work towards that. So I think that information was incorrect. And I'm actually very, very happy that I will join this, the person that was working on that, because got a prize on Monday.
Nice. Yeah, I think there was a combination of a lot of people and a lot of money working on a technology that had been developed already, and it was just the perfect kind of mix to get things done quickly. Dr. Nero, who we talked a couple of weeks ago, he mentioned that too. I can maybe send you the recording of that. I think he was kind of joking about it in a semi-sarcastic way that, you know, if we throw enough money and put the brightest people on things, then things can get done faster than we thought.
Yeah, exactly.
That was a really good question, Peaceful Warrior. Thank you. Are there any other questions from folks in the audience? Because our guest has to go in about 3 minutes. Is that right, Doc?
I'm already in the car now, but listen, my husband is driving. Don't worry.
Oh, your husband's driving. Okay. Well, you know what? There's not any other questions, and instead of forcing it, if you've got to get going to your thing, I think we'll just wrap stuff up right now. Dr. Valdez, thank you so much for being our guest again tonight, and we would love to have you back in the future to talk more about immunology. It's a really, really popular an important discussion and fascinating discussion. So, folks in the audience, if you are not following Dr. Valdez, please click on Janet's profile there and give her a follow. So you are, what's coming up in the future for you? Are you traveling or something, Doc?
Yes, we are. Well, the long COVID is something we're doing, but we also are, my husband and other scientists here, we belong to the group called Immunology Without Borders. So
Right.
we are heading to Zambia in early December. So we're going to be teaching there, and immunology, of course, and also a little bit of equity, diversity, and inclusion. So that's what's coming. So I'm preparing everything for our trip to Zambia.
Nice.
Yep. And also, if you have other questions about immunology, you can just text me DM me by Twitter. So I will do my best to answer any questions.
Awesome. I am so thankful that you're here talking to us tonight. That is amazing. I just wanted to mention a couple things as we wrap up here. So please make sure you follow our guest tonight. And our partner, Indra Bartona, has a space, and I'm just trying to put it up in the nest from a DM, and I cannot do it. So I apologize for that. I'm trying to put the reminder up there, and it's just failing me. I think we'll just tweet this out, and then I will put it up in the nest that way. That's the way it's going to work. Coming up. So Indra is in the chat tonight. Indra is our partner and runs spaces on positivity, mindfulness. Chris, did you have something to say?
Well, I was just wondering when to expect the information coming out about long COVID in Canada, the study. When might I expect to read a little bit more about that?
Yeah, it should be maybe in the next 2 weeks. We were really working this, and I can't speak directly now, but I will let you know as soon as it comes up.
Okay, I'm following.
Splash about that.
Yeah, I'm following you now. So when it comes out, I'll be like, woohoo.
So, Doctor, I'll let you go. Thank you so much for being our guest tonight. I did manage to figure out the technology, and I put Indra's space up into the nest. It's about introverts. So if you are needing some help with, being an introvert, that is an amazing space. Indra runs these great spaces, and we're super happy and proud to be her partner. We bring the science, and she brings the meditation and mindfulness. It's a great combo. Okay, so as we wrap up, let's get my wrap-up music going. There it is, the wrap-up music. Thanks again to our guest, Dr. Yane Valdez, talked to us about immunology. I have like another 20 questions about dendritic cells because they are the coolest thing on the earth. I'm going to go watch some more YouTube videos about dendritic cells. Please give our guest a follow. Again, Indra's Space is up in the nest.